college algebra courses. This summer, we... Is this a mic?
Yeah, no,
Yeah.
no, just
No, you put it around your neck and it follows you
Camera's gonna
everywhere.
follow
Yes.
Oh, okay. I got
Big
it.
brother in a box.
We both taught a college algebra course in the summer, so while this was going on and we were putting these problems together, we were discussing what was going on in our classes, the difficulties and so forth. So it's been a great opportunity to do that. Michael, did you have an introduction?
Yeah, you know, I've been teaching, it's been about 20 years plus now, and I've taught a variety of courses. But the main courses I teach over at Public Community College are calculus. I teach the survey course. I teach all of our calculus courses. And I've taught other courses like our tech math course and our college algebra course. So the deal for me is I'd like to try to find, I mean, I use a lot of technology in my classroom anyway, but the big thing is trying to get the students motivated to kind of explore where you actually use math, right? So one of the things I decided to do is to take, you know, some of the calculus problems that I run into and just kind of water them down for college algebra as an impetus, right? So calculus shows you where they come from, and then, you know, we're using college algebra, you know, this is what you're using them for. Yes. Good.
So we discussed why word problems, and I think both of us, I speak for both of us, take the view that this is one of the central, and maybe for us, the most important rubber meets the road skill of a college algebra student is to be able to take words that other people say, their requirements, their desires for what they want designed or improved, and to take those words and formulate an algebra problem, or formulate it in some way, with a picture first, or by many means, to try to make it more specific, to get better agreement among people about what we're really talking about and what the end result is. That translation issue, that literacy, I guess I could say, reading a problem and translating it into math, is greatly motivating as well, because then you want to do the algebra to find the answer. So one thing here is just motivating and stimulating the imagination. Little quick story here. I put the can in bold, what a word problem can do. I have been working in industry for about 22 years, and I like to ask people I work with, how did you get into this field? You know, why did you pick this, and so forth? And especially the happy people. But my director of 22 years, I asked him this question early on, and he said, oh, I was in calculus class, and the instructor brought in a can of Campbell's soup, and he said, does this make best use of the metal to contain the soup that's in it? And we used the calculus we'd been learning to work a problem like that. He said, I went home and I took every can off my mom's Lazy Susan, and I measured it to see how close it was to. He said, this captured my imagination, and I went into operations research. I think that's a wonderful story of what can happen with just one particular word problem. So motivation and imagination. Michael, do you want to say something about this one?
Well, you know, when the fact of the matter is that how do we, you know, transfer things in a way that the student can understand it, see the applicability, and how to integrate, you know, different styles of learning into, you know, what we're trying to get them to do, which is to solve a problem, right? And so the idea here that we were going to go with was we're going to try to do this open source course. I mean, that's what we want to try to do. So the whole thing about the way we would like to run the course, or try to set it up, is we give them the nuts and bolts, right? The tools. How do you solve equations? How, you know, what methods are you use to look at an equation, integration of technology. And then once we get those nuts and bolts down, the idea would be to give them a variety of problems and to integrate whatever learning styles they have into the solving of those problems, right?
Well, so we want to try to deepen understanding by engaging more of the senses, more of the imagination. We've specifically chosen to take our human heritage from various cultures and see how that history informs pedagogy. For example, 5,000 years ago, people were giving the same very similar kinds of word problems to people that were being trained to be civil servants. This is a persistent activity that's benefited civilization. Sustainability was our focus. We were working on trying to create and find sustainability problems. And so sustainability has to do with long-term planning, and this kind of activity comes into that. Has to do with seeking efficiencies in the use of energy and human resources as well. Optimality is sometimes viewed as the ultimate of efficiency. On the other hand, in the end, you have to choose your objective. That objective depends on what you think the goods are and the values are that you're trying to achieve in an efficient way. But if you choose bad objectives and do them efficiently, that may not be sustainable, even if it's optimal. So what we want our students to understand, there's a difference between getting efficiency and optimality, a mathematical process maybe, and actually having something sustainable. Those are two separate issues. You can do bad things efficiently, right? You can,
oh yeah.
So where did we get our problems? And I'll run this through quickly. And then we've just got 3 sample problems from the 60 that we selected and created. So we went to various textbooks. Michael was saying we didn't stick to college algebra. Up and down, things lower, things higher. Where does this algebra lead? We chose from our knowledge and what we could find from space science, natural sciences, engineering, and business type of applications, and just regular geometry, fun things. Problems from population and resource depletion modeling. Because we were looking for sustainability issues, we wanted to try to find something there. And then, as I said, history, so we can bring in the many cultures that mathematics and problem solving come from. So I'll talk about this one, Michael will talk about the next one, and then maybe both of us the last one. Well, here's a problem that would often be in a differential equations class, but the real analysis is based on algebra. It's a parabolic function that describes growth rate in what would be called the logistic model, and this has a certain habitat, has a carrying capacity. So we want students to run into this idea of a maximum carrying capacity of an environment or a habitat, and yet use their quadratic modeling. And have some kind of a discussion, what's the fastest this grows, where does it reach equilibrium, where it can stay at the same value over time. Yeah, one way to go is it can be extinct. No animals. That's
stable.
That's just, yeah, stable. But we'd rather not have that, right?
And there's an efficient model, that's not a good idea, right?
Yeah. So these issues, these higher level issues of optimization versus equilibrium and so forth. Does this persist over time?
Yeah, this one is a very good example of something involving resources, the depletion of natural resources, right? Because usually, especially when you're trying to acquire a resource, usually that growth is exponential, right? So in this particular problem, we have an idea that at time t equals 0, when this is measured, we use a certain amount of, let's say in this case, copper ore, like in 1997. And the amount used over a time interval ends up being given by this equation. So the idea is how much you're going to use in a future year if the growth rate that you're acquiring the copper ore is exponential, right? And there's also a companion problem to this is if this is how much of the resource we have totally on the planet, how many years will it be before it's gone, right? And this is a good sustainability problem because this gives the idea that things are finite, right? I mean, this gives the idea that if you are desiring some sort of thing that's important for your infrastructure, it eventually is going to go away, right? And you only have this finite amount of time. So, especially if you're doing an exponential growth model, that time is a lot closer than you think, right? I mean, especially if you're thinking about like oil depletion or water resource depletion, and California is dealing with this right now. I mean, this gives a good physical, that's not a lot of time, right? Well, that's 20 years, that's 10 years. That gives the student a real hands-on, oh my God, we're in trouble, type of idea.
So, as our third and last example, here's an example of a historical problem. This comes from the sea mirror of circle measurements. I love the Chinese titles, so natural and evocative. So, in this problem from the Middle Ages Chinese mathematics, we have a problem that gives us, in our algebra, a 4th degree polynomial to solve, which with large coefficients is difficult. And so, 2 things going on here. a student certainly is going to be motivated and encouraged to look at it, see what they can learn about it, but then go to their technology, a computer or something like that, and see how they can use that to approximate the roots or to find the roots. But then to reflect on, did the Chinese have this calculator? They solved it. So the idea that there's a people almost 1,000 years ago who somehow were able to come up with a solution by their hand methods, abacuses, and so forth with another form of technology. And you should be blessed to have this, but keep in mind it's still possible. A little serendipity here. As we were checking out the solutions, I've worked it 4 times, kept not getting the answer that was apparently the answer in the historical report about this problem. And so what does a student have to do when the answer isn't the same as in the back of the book? Find another means of solving it, or another friend who can solve it, and compare. Well, so I kept getting that answer on the top, and the source gave the answer on the bottom, so I got the solution to both of those, and I just drew a picture with a ruler, and I found out that mine was correct. It actually solved the geometry problem that we wanted to solve about how big is this city. This kind of problem where there's many sources of access to the information, I find to be rich and beautiful. Also the question, don't just trust the printed source, think about what it means, and so forth. So, kind of tying up here, our dissemination has been and will be in our own individual Math 121 or college algebra classes at the 2 institutions. We'll put this up on the iDrive in the Math 121 folder. If anybody else wants a copy of what we've done, please ask. And then we're considering, as Michael said, building some open courseware in which we will just continue this development of problems, testing in the classroom and seeing how motivated they are and how they work. And you want to say it?
Yeah, one of the things I use my calculus courses extensively is Mathematica. And, I mean, it's basically restricted to my calculus courses. I'd like to expand it into the trig course. I'd like to expand it into the college algebra course at some point, try to do something. It's really not that hard of a technology to learn, and I can walk them through the command codes. But there's a number of lab projects that would be really useful to see for the student to graph these things and to interact between doing the mathematics. Mathematica is great because you do the mathematics and then you can write about it. You can actually write a project report. And I would like eventually to try to find some way to get this into Math 121. First of all, I'll give the kids a head up when they come to my calculus class. But Mathematica is a great tool, and I think it's very important to bring technology into the classroom. It's year 2015. I think it's time, there's a lot of pushback against using technology in the classroom sometimes, but I think this is a good utilization. That Chinese problem would be perfect for this is what this technology is designed to do. So I would like to see that happen eventually.
So just to kind of sum up our own individual experience working together and thinking about what was happening in our classes, we talked about content delivery, testing, and audience. We talked about programmatic issues that surround how we behave in the classroom, like what is the faculty qualification issue that's pressing on us from Higher Learning Commission? What's happening with faculty in that regard? How are we going to meet this challenge? What are our evaluation systems? PCC has just changed that, and Michael was able to give me his form and so forth and discuss how that was working out and what the response has been. Issues of placement, how do we deal with unprepared students to try to both encourage and yet indicate what standard there is to be reached from where they are, and give them support. How do we deal with attendance, homework, and other things? Michael, do you want to?
Yeah, we discussed how we taught word problems and how we incorporated it into our classroom at the present time. And we talked about how, like in our classroom, we use the calculator later on for the more complicated problems, but initially we do the usual, draw the nice polynomial by hand, but with an eye to the fact that not every polynomial is nice. See the word problem about the Chinese word problem, or see something done by regression on a business optimization problem, right? So there's a lot of utility where you're gonna have to use the technology whether you want to or not, because the problems are that complicated. And of course, I discussed Mathematica. One of the other things too we kind of wanted to try to do is maybe rearrange the way college algebra is taught. I mean, we were going to talk about how, the way it's taught now is taught in 6 chapters, and it's taught with an eye toward functions, or kind of like in the middle of a course. And when we were doing this, we came up with an alternative method where we were actually dealing with the type of functions rather than functions in general, right? So.
And it's been just great to interact. I think we've already communicated that, and it's been a wonderful thing. And we find it, we anticipate we're going to have a lot more interaction with PCC Math Department than we used to, because we have this contact way of discussing things. And here's some sources, and we had numerous other ones, but just so.
These are big 4 ones.
Yeah.
So.
But thank you for this.
Thank you much. No, not me. I didn't have it on.
Oh, yeah. I'm off the leash.
I said, big brother in the box.
I know, it's pretty cool. So take some time. I guess a couple of things that really stood out for me was the sustainability approach was definitely a very core concept to embed. I actually had a situation one time where we were talking about sustainability, and speaking of China, there was a student in the classroom who was she was half Chinese, half white, or half U.S. born, and so her dad was white and her mom was Chinese. And when we talk about sustainability, somebody in the class started saying, "Well, if those Chinese would just stop using resources," but she just sat there. And I just want to point it out because it's one of those real things. And your example obviously wasn't like that, but I want to point out, what would you do if you heard that comment when it came to inclusivity? How would you react as an instructor, when it comes to, and the student just sat there. She didn't say anything, but afterwards she shared with me, she goes, "I was so frustrated with that instructor, he didn't say anything." And he goes, "And my family's from China." So it was really a very interesting, eye-opening experience for me when it came to how do we provide that safe space for our students, right? And definitely a situation I've never encountered elsewhere, but it was such a real situation for her at that moment. So just pointing, when it comes to inclusiveness, we might not think about it, but it's definitely really relevant when it comes to math and the choice in how you approach a certain problem. So take a couple of minutes to write your feedback to them, whether it's, and if you've already done it, thank you. And then once you're done with that, go ahead and pass it to them.